So I'm going to talk about the basics of calculus. So calculus is essentially um, you start with derivatives, and what a derivative is its instantaneous rate of change um, at any given point, right? So you have this function, like in this case, you have a distance time function, right? So at 0 seconds you go 0 meters, at 1 second you go 1 meter, then at 2 seconds you go 4 meters in displacement, and then at 3 seconds you go 9 meters. But what is the instantaneous rate of change at all those given points? That's known as the velocity, and that's in meters per second. So how you actually get meters per second is you take this axis divided by this axis, and that gives you your actual unit, right? So at 1 second, you have 2 meters per second for your velocity, and then every point in this case, since our function is 2 to the second, you always have 2 as your meters per second squared. So this is how I defined the functions in this case. It's not always going to be this way, but f of t is 2 to the second. F prime of t is the derivative of that, or the velocity function, which is 2t, where t is in seconds, and the output is meters. So f double prime of t is equal to the acceleration, and that's just equal to 2, right? So essentially what we're doing here is we're trying to figure out the instantaneous rate of change. So this is the instantaneous rate of change at any given point in this window. So we have 0 through 5. This is 0 at 0 seconds, which there'd be a tangent line right here, which would be flat. 2 here. So the ones that I have plotted are at 3 and 4. So if you look at 3, essentially what it is it's the slope of this tangent line is 6 meters per second. The slope of this tangent line is 8 meters per second. And the acceleration of this curve is 2 meters per second squared. So this is what the derivative function looks like, or the velocity function in this case. And this is time in seconds to velocity. So if we took instantaneous rate of change at any given point, it's just going to be 2, and I showed that above. So essentially what that means is if we take delta y, which in this case is 2, and delta x, which is 1, and then did 2 divided by 1, we just get 2. And that's the same at any given point here, right? So that's your slope. So this is what the acceleration function looks like. Like I said, it's just a constant value that runs through. So that's kind of like the basics of derivatives. I hope you enjoyed. Thanks. Bye.